Welcome viewers, in this video we will see the equation for copper saving in Autotransformer. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we will go to the topic, equation of copper saving in Autotransformer. We know that there are two type of transformer, two winding transformer and Autotransformer. With it, this Autotransformer, the copper is saved. We are going to frame the equation for copper saving, because in Autotransformer we are using only one winding, that is for both primary as well as secondary. So automatically we will get the copper saved. The amount of copper used is lesser. For that we are going to frame the equation. So for any winding, the cross section is directly proportional to current. The cross sectional area or the area is decided, the size of the cable is decided by the current I. Similarly, the length of winding is directly proportional to number of turns N, right. So the current will decide the size of the wire, the length of the wire is decided by number of turns. So totally the weight of the copper is directly proportional to N into I. So these two are the primary factor deciding the weight of the copper. So I refer the area, N refer the length. So totally the weight of the copper is proportional to N into I. Now we will see we will compare the two winding transformer as well as the Autotransformer. So this is the two winding transformer, that is primary winding and secondary winding. We have primary winding and secondary winding. So the N1 is the number of turns available in primary winding, N2 number of turns available in the secondary winding. I1 current in the primary winding, I2 current in the secondary winding. V1 is the voltage applied to primary winding, V2 is the voltage available in the load terminal of the secondary winding. Now we will go to the Autotransformer. In Autotransformer we have only one winding is available. It is given as the name A, B and C. So the entire AB is used as a primary winding. Here we are compare the step down transformer. So the entire winding used as a primary winding. The part of the winding used as the secondary winding, that is BC. Only BC is used as a secondary winding. Now we will compare with the current. The current in the primary winding is I1. Current in the secondary winding is I2. But this is the common portion. Here both primary current and secondary current will flow. So the difference between this primary and secondary, I2 minus I1 is flowing through the section BC. Right. So I1 is primary current, I2 is the secondary current. In a common area BC, I2 minus I1 current is flowing. Now we'll see this number of turns AB. AB is nothing but primary winding. Number of turns is N1. BC is the secondary winding, is N2. Suppose number of turns in the section AC mean N1 minus N2. N1 refers the primary winding, entire winding. N2 refers the section of common section of winding BC. For the case suppose if we need the winding in the section AC mean the difference between these two, N1 minus N2. Now our aim is we need to analyze the copper required for the two winding transformer as well as the Autotransformer. Let us consider WTW. TW means two winding. WTW is the weight of the copper in two winding transformer. Let us assume that WTW. WAT is the total weight of copper in Autotransformer. So now we are going to compare these two. What is the weight of two winding transformer? What is the weight of Autotransformer? First we will see the two winding transformer. Weight of copper in primary winding is N1 into I1. We already discussed the weight is depends upon the number of turns and current. So primary winding means it is N1 and I1. In case of secondary winding means N2 I2. So the total copper required is N1 I1 plus N2 I2. So the copper requirement in the two winding transformer is N1 I1 plus N2 I2. Suppose in case of the Autotransformer, the weight of copper in the section AC. Section AC is directly proportional to N1 minus N2 into I1, because in AC AC is the section in the difference between this N1 is the primary, N2 is the secondary. AC mean the difference between these two is into I1, because I1 is flowing only in the section AC. Similarly, weight of the copper section BC is N2. The secondary winding, the number of turns is N2, but because of common area, the current flowing is I2 minus I1. Right. So, we need to see AC and BC. AB is the total weight of the copper. Here we are assume that this is the primary winding and this is the secondary winding. So, in the primary winding, number of N1 is the number of turns, but in the section AC, N1 minus N2. BC act as a secondary winding, so N2 into I2 minus I1. Right. So, totally we are considering A to C and C to B. So, the entire winding we consider. So, the total weight of the copper is N1 minus N2 into I1 plus N2 into I2 minus I1. Right. Now, we will refer the diagram so that. So, this one we consider AC. AC mean N1 minus N2. The current flowing is I1. Similarly, the second section BC. BC number of turns is I2, N2, but the current flowing is I2 minus I1. So, we consider AC and BC. Now, we will compare the weight of two winding transformer and auto transformer. So, by taking the ratio, in order to compare, we are taking the ratio of two winding to two weights, WTW divided by WAT, that is weight of the two winding transformer divided by auto transformer. So, N1 I1 plus N2 I2 divided by N1 minus N2 into I1 plus N2 into I2 minus I1. Now, we will multiply inside, so that N1 I1 plus N2 I2 divided by N1 into I1, N2 into I1 minus plus N2 into I2 minus N2 into I1. Right. So, what we have here, we have N1 I1, N2 I2. This N2 I1 available 2 times, minus negative minus N2 I1 available 2 times. So, that minus 2 N2 I1. So, after simplification we got this value. So, by using the transformation ratio, we know the transformation ratio K equal to N2 by N1 or I1 by I2. In case of current, it is reverse, N2 by N1, V2 by V1, current is I1 by I2. So, from this we can write N2 equal to, cross multiply this, N2 equal to K into N1. Similarly, in this I1 equal to K into I2. So, this I2 equal to I1 by K. Right. So, we are getting the value of N2 and I2 from this equation. Right. So, this N1, K and N1 is multiplied, so that N2 equal to K into N1. Right. So, this I2 is brought in the numerator, K is brought in the denominator, so that I2 equal to I1 by K. Now, we will substitute these two values, N2 and I2, in the above equation. So, WTW divided by WAT equal to N1 I1 plus N2 is nothing but K into I1, N2 is the K into I1. Similarly, I2 is I1 by K, that is substituted, divided by N1 I1 plus K N1 into this I1 by K, I2 is substituted, I1 by K, minus this, again it is substituted, K N1 into I1. Now, we can simplify this, this K got cancelled, here also cancel, here also cancel. So, finally, what we have, N1 I1 plus N1 I1 divided by N1 I1 plus N1 I1 minus 2 times of K N1 I1. So, all terms are available as N1 I1, both in numerator as well as the denominator. So, we can take this N1 I1 common. So, that here 1 plus 1 divided by, here also we can take common. So, 1 plus 1 minus 2K. So, this N1 I1 got cancelled. So, 1 plus 1 2 divided by 1 plus 1 2 minus 2K. Right. So, this 2 also commonly available, everywhere 2 is available. So, that we can write WTW divided by WAT equal to 1 divided by 1 minus K. Right. This is the finally what we got, the weight of the two winding transformer divided by weight of the auto transformer is 1 divided by 1 minus K. So, by cross multiplying we can get WAT equal to 1 minus K into WTW, weight of auto transformer equal to 1 minus K into weight of two winding transformer. Now, we will multiply inside. So, WAT equal to WTW minus K into WTW, right. So K into WTW, this term is brought in the left hand side and this term is brought in the right hand side. So that K WTW equal to WTW minus WAT. So this is the difference between this two winding transformer and auto transformer. So we can write WTW minus WAT, that is the difference in weight between the two winding transformer and auto transformer is K times of WTW, right. So that is available as K times. The K is nothing but is a transformation ratio. So it is given as saving of copper, that is the weight of difference between primary and secondary winding is K times of weight of two winding transformer. So this is applicable for step down transformer, right. So what is the meaning? The saving in copper is K times of total weight of copper in the two winding transformer. So this is K times. In case of step up transformer, it is 1 by K times of WTW. Previously K times, here 1 by K times, right. So the by referring the transformation ratio V2 by V1 equal to N2 by N1 equal to I1 by I2. So in this video we discuss about the equation of copper saving for a auto transformer. We will compare with the two winding transformer. We got the expression, that is it is the K times of copper saving is K times of a two winding transformer in for a step down transformer. For step up transformer 1 divided by K times. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Thank you for listening.